I can start streaming.
So if you ask, you can tell me
Okay, so is everyone on Databricks already?
No, not me.
Okay, so yeah, so I recommend watching these videos. They're like a good subset of the videos in the course. So let us sort of play around a little bit. So if we go here, and then we go, there's these nice little introductions, Introduction to Apache Spark on Databricks, for data scientists, Introduction to Structured Streaming, for example. So it comes with a lot of docs actually. And here, for example, so this is a Python notebook. It sort of opens. I'm just sort of showing you around like a little bit about navigating. So if you go to the workspace, you see there's documentation, release notes, training and tutorials, and so on. And usually your username is here. So you can. So I have put various libraries I use, so we can add libraries that we want. So I use Google's JSON for processing JSON files, graph frames, whatever. So we will play around more. There's some Twitter libraries. For you, it will probably be empty now. And we can go to training and tutorials. This opens its own link. So this is a very good set of resource that we should, for example, there was analyzing 1,000 genomes with Spark and Hail. And, I do not have infinite time like everyone else. So, so if you're really into 1,000 genomes, maybe quite soon you will be able to start playing with this. Okay, so let's see. The courses I have been sort of putting these YouTube videos on. They are here. Introduction to Big Data is the AJ's course. And you see, it's the full course. So I've just been sticking some videos for you. So I kind of crash ran through the first module of this course, actually, yeah. But you can watch it more calmly on your own time if you like. It's quite good. It takes time to watch videos. So we will rely on them in subsequent lectures as well. The ones I think are good, I put them there, and I usually only give you quick comments because I don't want to waste our interaction time on videos you can watch offline. But we will focus more on just getting our hands dirty quickly. So I guess Amit Talwakar's course must be here as well. Here, Scalable Machine Learning. So it's quite good. I will be borrowing a lot of materials and videos from here as well, and embed them as we progress along. So some of the material is slightly older, but of course the map isn't, and the ideas aren't. Okay, what else? So let's go back to our main course, and we go. I've assumed everyone is logged on to Databricks. So what this notebook sort of walking you through is essentially what is a Databricks cloud in a super big hurry. So you can read this in detail later. And I myself, because this will be live and it's going to evolve. So we can come back that for details. But quickly, Databricks or cloud or DBC essentially is a platform that's fully managed for you. It's running Apache Spark, which is fully open. I don't know, it's like a huge community. People from all over the world are committing code, so it's expanding fast and so on. The Databricks cloud has a Databricks workspace, which is where we will be working, right? So that's right here. Sorry. So here's your workspace. So you have your own stuff and other things like this. So here are some swear words in this world. So there's something called a shard, a cluster, a notebook, and a dashboard. Okay. So dashboard is kind of gone. It's slightly old content, but shard is basically an instance of Databricks workspace, right? That's the abstraction. A cluster is actually the cluster of some commodity computers that's running in the background, currently in AWS, because Databricks uses Amazon Web Services for its hardware. Okay, so you can we will launch our own clusters. Okay, so you can have multiple clusters per shard. Okay, so shard is this instance of the workspace. So a professional version of Databricks will allow multiple programmers and data scientists to work on the same workspace, okay, in the same shard, and we can have multiple clusters and connect your notebook to different clusters and things like this. But the community edition doesn't allow collaboration. So, okay. So what's the high-level idea? You have a shard, and people in a team can log in through a browser, and they can have local copies of the code that they are writing in these notebooks on the browser. In the professional version, that notebook's source code can be committed automatically to GitHub, which is this collaborative version control system for sharing code. But I don't think that comes in the community version, so you have to do import and export local copies or from URLs. And a notebook can be detached or attached to Spark clusters, the physical computer clusters under the shard. And of course, those clusters are in the cloud, which is your big data center. That's the picture. Okay, so now let's get into the Scala crash course notebook. And let's right-click, copy link address, and let me go to my here. So what I can do is import from URL, and then I paste that URL. Okay, 003 _ Scala crash course. So that should just bring that notebook into my community edition.
Should we try to follow you?
Yeah, it'll be good if you follow me, because that'll be good, especially for
Can you wait a minute or two until
everyone? Yeah. So please, yeah.
Could you show again what?
Yeah, sure.
Yeah, especially for gifted.
Yeah, no problem. So let's go back here. So you see,
where is it?
So okay, this is basically where we're going to be, right? So this is essentially Scala crash course on the left. You see.
Mm-hmm.
So I click that. It brings me here.
Cool.
And all I've done is sort of embedded that notebook in iframe in there. So you can't. So then you have to sort of right-click that an importable Databricks notebook link, copy link address. Yeah. And go to your thingamabob, and so if you hit your workspace. So for example, you can create a folder. Let's do that. So maybe create a folder, call it whatever, SDS. And then in that folder, you see that little triangle. If I click that again, I can create a notebook or clone, whatever I want to import. And then I click URL and I paste that. So now I'm importing the notebook via that URL. into this folder I created.
So you go on the users after. I see clone and expert, right?
Yeah.
What do you do after?
So you do
DBC or
import. No, not there. So you go into your home directory, and then click that little triangle.
Here.
Yeah, right there. Yeah. Now you say import. Yeah. Cool. And then URL. Paste.
Cool.
Is everyone on this world? Same one. Good. Don't think Alexei is slow. He's holding all the hot pipes at Commune. So, okay. All right. So now what we're going to do is okay. So forget about some of these comments. Yeah, because it was a different model. So don't forget about the student enroll, student observing. I will fix the notebook tonight. So the point is, notebooks can be written in multiple languages, right? It can be a Python notebook, a Scala notebook, an R notebook, or SQL notebook so far, right? So to create a new notebook, this is kind of the idea. So you go to your home, you click the triangle, you hit the create button, then you hit the notebook, okay? And then when you do that, you can choose whether you want the language to be Scala, whatever, or whatever. So let's do that example. So I can go here and, I'm going to create a notebook. And then I'm going to say my notebook. I think it'll default, by default, it'll throw you Python, but you can go here and choose Scala. Okay. Yes, this course is completely Scala. There's a reason for this. Okay, so your Python skills are still good. We will use them when the appropriate libraries under the hood are needed. But Spark itself is written in Scala, so Scala will be our primary language. So then I say create. Right, so that's it. So if you want, so I generally do this. I just sort of so if you go, so let me just, so let's say we're in here. I'm not sure what order I'm going to do stuff. So if you do %MD, this becomes now a markdown cell, okay? So now I can type pure markdown here. All right. This is my title. Okay, so 1 hash is just the first header. Okay, so if I do 2 hash, it's the second level header in Markdown, right?
Can you please?
Sorry?
Font size, or make it
Oh,
bigger.
sorry, thanks. How's that?
Yeah.
Yes. Then I am learning Markdown header level 1 and header level 2 and writing this in a paragraph now. Okay, so whatever, this is just basic Markdown, and if you get out of the cell, it'll evaluate the cell. Okay, so maybe I'll make it one tiny bit, little bit. Is that okay still? So then that's Markdown, right? That's how I'm making your notes. So your project, you will be writing a notebook, and you will need to know some Markdown. Okay, now, okay, before I go some random path, I thought about this a little bit, so let me go back to the actual notebook. And let's do the next task here. Creating a new notebook, choosing the language. and cloning a notebook, right? So you can clone a notebook, which is just a copy of it, by going to File and Clone. Right? So let's clone this notebook. I think, yeah, if you guys are bored, you can go. So just hit clone. So now, and then it says, because it puts a parentheses 1 because it wants to make unique names for the notebook. So then I can say clone. So this is a good idea, like if you want to mess around with the notebook and not destroy the original one. So you can do this. Unfortunately, I need to go a bit smaller. Yeah, because otherwise I can't see the button, right? So the button lands. Okay, so I'm just going to say, and I can choose a different directory or the same directory. So I'm going to choose the same directory. So I've cloned it. Okay. What are the other important operations I want to be able to do? Clone a notebook. Introduction to Scala. Okay, so it'll be nice if we get through this today, then we can start doing resilient distributed data sets tomorrow, which is important to finish your assignment, which I'll hand out on Friday. So the assignments will be due, yeah. Okay, so how do you attach a notebook to a cluster? This is the most important thing. So currently, Markdown is okay, because that's rendering and stuff, but you really need to run a cluster to start doing actual computations, right? So what you have to do is, say here, create a cluster. So this is a cluster name. Well, you can call it whatever you want. I'm going to call it Atlantis. I think that's one of my favorite Swedish characters. You know, the guy who believed we were in Atlantis, right? I went through some museum tours and they're telling me it's pretty interesting. Do you know his name?
Vaza.
No, that's King, man.
It's sank.
Anyway, sorry. So it's we can jibber jabber because the cluster is being created, right? So this is a very lightweight cluster. It only has 6 GB of memory. Okay, it's optimized for sort of. So it's not a lot going on, but it's enough for us to learn a lot. Okay, so Databricks is giving this for free because they want you to, eventually think how simple it is and pay them, right? So for this managed service, that's their model. Okay, so it's done. It's Apache Spark 2.2.0 and Scala version 2.11. This is what's running. It's on demand. On demand is the AWS language. It means it's going to be there, right? So the other model is a spot model. Someone correct me. I think I might get. Yeah, that's correct. The spot. If you buy a cluster, if you pay for a cluster on spot prices, then when the spot prices go down below what you're willing to pay per hour, then you lose your cluster with a 1-minute notice or something. So this is on demand, so you don't have to worry about it. Okay, so in my world, I have libraries. We'll get to that later. So now, the cluster is running, so let's go back to our most recent notebook, which is either the clone or this one. So if I go to the clone, it will, I have to say attach to this cluster I just created. Okay. So attaching this notebook.
How do you do this?
So let me go back to recent.
Yeah.
So you remember the other notebook, which is not the clone, the original one. I'll show that. Okay, so I'm there. Now I go to this thing. It says detached.
Cool.
It says because the status it's detached to a cluster. And this icon is like a cluster icon, whatever. Sorry, I have to click this triangle and
so my cluster is still pending.
Yeah, so that's probably because they're all launching it, and I don't know.
Yes, perhaps it was the wrong name, right?
It's probably running in Dublin, I think. I don't know where it runs. Probably Dublin or Frankfurt has one, right? Or somewhere in Germany. This one was US, we Oregon.
Yes, it was yours.
West Coast. Anyway, it doesn't matter because they are paying for AWS for all of this, right? Databricks is paying for this for free. So now what do? We just basically, is everyone at this point created a cluster, attached the notebook? Okay. Okay, so yeah, this I already gave you now. I gave you a tutorial on how to do Markdown. So %MD is Markdown, and you can learn a lot more about Markdown Wikipedia, but you know. So if I double click that cell, opens, and if I want to create a new cell, I can go to this plus, insert a new cell. So that I can insert a new cell, and I can do something else here. And remember, this is a Scala notebook, right? So I can type something, 1 + 1, because because it says here Scala, the default language is Scala. So I don't have to put %Scala on this notebook. So first hit will take a little more time. Okay, so the answer, the result is integer 2. So we just ran our first Scala arithmetic, adding to integers. Okay, this is just a little tutorial on how to say hello world with %MD. Right, so essentially you see this is the rendered version. So if I double click here, I see the code, right? I'm a little anal about my syntax. I usually like to put underline. Just know that's not mandatory. Okay. Okay, so now let's do a bit more. So to run the cell, I have to do Shift Enter, right? So let me say I put here println as print line. It's a Scala command. And I'm asking it to do system current time in milliseconds. So if I go into the cell and do Control Enter, it must be Command, and I don't know what it is in Mac. Shift Enter, right? And when in doubt, you can just like when I sometimes start playing now with my fancy iPhone 7, and you can press this button, Run Cell, and then it's a yeah, agnostic to the. Okay, that's our current time. Scala Resources. So these are essentially sort of resources to learn Scala. This is probably hardcore, good thing. Martin Odersky is the founder of Scala. There's a Scala by example book. There's a course in Coursera by him. It's running right now. So if you really want to get into Scala, especially if you want to be a data engineering scientist or someone closer to the engineering end and software engineering end, you should really learn the language properly. Okay. So what is Scala? It's an interesting way of integrating object-oriented and functional programming. It's kind of how I mainly see it, right? And this is also the quote of the founder. So I don't want to get wars with computer scientists about languages, so I do C and C++ for my own research and MATLAB and Python and everything else. So, but it's designed to express common programming patterns in a concise, elegant, and type-safe way. So it's a high-level language. It uses Java virtual machines, so everything is bytecodes, and it makes it sort of operation system independent and things like this. It's object-oriented and functional. It's statically typed. That means it's very precise about the type of each variable and so on, and the types are done statically. So at compile time, you already know if you're breaking something. It's comparable in speed to Java, and there's also type inference that comes with it. So you don't have to be explicit and say the types all the time. It can use any Java class. because it can inherit from any Java class. So all of the Java research and the libraries are all underneath Scala, so naturally. And it can also be called from Java code. Okay, so why are we using Scala? Spark was originally written in Scala, which allows concise function syntax and interactive use. There are APIs, Spark APIs for other languages, but because Spark is developed quite rapidly from lots of companies and people all over the world, the primary place where all the development is happening is in the native language of Scala. So if you want to be a company and want to be competitive, it's important to actually get every juice and every little innovation quickly. But of course, when you start working in Spark 2.2 at a higher level of abstraction, which we will get to in a couple weeks, which are called data frames and data sets, then it's almost language agnostic, because it's more like feeding your sort of syntactic love of a language rather than, because everything under the hood is still done in the same bytecode. But that's good for most of data science purposes, but if you want to build a product, you may really want all the speed you can get, and you may even want to start writing directly from the primitives, which are resilient distributed data sets. And for example, this book, High Performance Spark, it's very current, is about best practices for scaling and optimizing Apache Spark, and they really recommend Scala, for example, given that the author is actually a PySpark committer. So that's the other main reason. So from a computational statistician's point of view, there is Darren Wilkinson, who's an English statistician, hardcore coder and stuff. So for him, this is from his research blog, why is Scala a good platform for statistical computing and data science? Right. So you can read this blog. He sort of really gives this feature wish list and compares it to R and so on. So I'm not going to read this for you. So now let's get our hands dirty in Scala, right? So here are the concepts we'll quickly try to go through in the next 10 minutes. Assignments, methods and tab completion, functions in Scala, collections in Scala, and Scala closures for functional programming and MapReduce. And if you don't know what these words mean, don't worry. You just need to understand what's going on as you hit Shift Enter at some level. So assignments, right? The fundamental thing we want to distinguish, say, relative to Python or MATLAB is val and var, right? Val is for value, var is for variable, right? So what I'm going to do here by control entering is I say val x colon int. So I'm saying the value named x is of type int, and it is assigned 5. Okay, so I just control enter there, and now I got my command evaluated. Okay, so int equals 5. Now Scala is statically typed, but it uses built-in type inference, like I said. So you don't have to explicitly say x colon int here, like we did before. You can just say x equals 5. And when I just enter, evaluate it, it still gives me the same result, int equals 5, right? And the reason it was able to do that is because it looked at 5 and it knows 5 is an integer type, because I didn't do 5.0, for example. Now it's going to complain probably. Or it'll do double, so it'll infer that the type is double. I'm kind of jumping the gun a little bit, okay? So let's declare x as a double, or double precision. That's what I just did. And so now it will automatically infer that it's a floating point number, double precision. Or I can also explicitly say it, But now I don't have to put the 5.0. I can put 5.0, and it'll still say x is a double, but I don't have to because I explicitly say that it is of type double, so it will know that. Okay, and please raise your hand if I'm going faster or whatever. So next, note that the labels need to be declared on first use. So we've declared x to be a val, right, which is short for value. So this means x is immutable. It cannot be changed, right? So thus x cannot be reassigned. So because x was a value double, and if I try to reassign it to 10, it's going to complain. It says error, reassignment to val. It's not allowed. Okay. So I'm going to just comment it back. So of course you can, declare it to be a variable from the beginning, right? So var makes y a variable. So now I say var y equals 2. Of course, now I can reassign y to 3. Okay, no worries. Okay, so and there are other things like lazy evaluations and defs versus vals. We'll kind of see the minimal things we need as we go, because we cannot deep dive into Scala. It's like a full course. Okay, so methods and tab completion, this is useful. So I'm now saying val s equals quote high. So you type in first that high is s is a string, which equals. So now what I can do is, go to this s and put a dot after it and then hit tab. Then it should tab complete and show me the options. Show me the methods that are applicable on. Are other people able to get it? Okay, so, all right, that maybe something.
First space, I think.
No, you need to run the command above first, right? To declare S.
What did I? No, this is just a picture.
The one above that one.
It's not actually evaluated around, you just cache the output.
Oh.
For me, I had to do space after the dot.
Oh, really?
Space?
And then a tab.
Space and a tab. Oh, why is that?
Now you get completion for everything in the notebook, not for the member.
Yeah, exactly. Exactly. So that's a good point.
Try removing the dot and typing it again.
Aha. Now it says.
Yeah, but yes. And now dot. And
Yeah. Yeah, sorry. So this was working. Okay, anyway, this could be just okay. The point is, maybe normally you can tab complete and find the methods for that variable, right? So
I think it's just very slow because it didn't work that much.
yeah, it's going to Oregon and back, and I don't know. My machine is going crazy because the open broadcasting OBS tool is like. Anyway, we're almost done. So. Okay, so this is just some examples you can kind of follow on your own even. So S, if I just shift enter, it'll just return this value. And if I can ask, and the method contains, does S contain the string F? False. Does S contain the empty string? It's true, because an empty set is a subset of any set. Does S contains I? True, because I is in high. Okay, so this is just an example of methods. So functions are fairly straightforward. It's like Pythonish. So you have definition of the function, and this is the name of the function square. And then inside the parentheses, there is the input argument to the function, which is x, and the type of the input argument, which is int, and then colon, and what is the output argument type? That's also int, and then sort of equals to, and what is the body of the function? So in this case, just x times x. So that's my definition square. Now I can evaluate square on 5, and I can find out what y is. Currently, it's 9. Sorry, y is 3, and I square y, that's 9. And now I know that x, which was the 5, that was the double. So I square x, and then I get my result to be a problem. Because my function square was not implemented on the double type, right? So that's sort of, this error is natural. Okay, so this is actually essentially what statically typed, static typing allows you to catch before you start running some stuff.
Should maybe be said that you can write a square function that works on anything that has a multiplication. So I mean, it's not just an inconvenience. it's flexible enough to allow you to express more
Yeah.
polymorphic things.
Yeah. So how would you do that? So
So-
Control A, Control C. So if I don't put the type at all,
Then it should do first, I guess.
so let's say I don't put the type. I mean, I'm just yeah.
What happens if you just run it without the colon?
Oh, I don't know.
Does it figure out the type class for you? Right. It wants the return type, but you have to write make it a generic and add a generic return type.
Yeah.
But don't.
Okay,
This
so
is
yeah.
advanced.
So we're just like playing right now. Like the point is, yes, you can make this generic. So anyway, okay, so this is just defining the function. So now I'm essentially just putting. I don't have to explicitly say return answer. If I just put the last thing, it'll just throw it out, the output. Now I'm squaring 5,000, and that sounds like the right answer. Now I'm sort of writing a function called announce and emit. It takes an input string and it just prints the input that was given to it, and also returns the value back. So that's the string, and here's a announce and emit. Just putting Roger, Roger. Okay. And this is Scala collections. So I have a list. And I've declared it to be immutable because I'm saying it's a value, LST, which equals list 1, 2, 3. So it's a list of integers. It's inferred. And then this is array. So an array, which is another container, and seek is a sequential container, which usually is a list. So these are things we will use. And here's Scala closures for functional programming and MapReduce. So I don't want to keep you guys here longer than you need to. We can continue from here. And this is essentially what we will need once we, I think this is enough to do our first hello world word count. Or do I have till 12:15?
I'm listening. I'm listening with a delay.
All right. So let's maybe stop at the closures, right? You guys can play around, and of course you can knock yourself out. So how is this? Is this useful for you to come here and listen to me? Because if you're here, it's better because then I can actually jazz this up. But if you cannot come here for some of the meetings because you're busy at a conference or whatever, doing other things, then you can always catch up on these YouTube things, which I'll try to do. But I won't promise that everything will be on YouTube, but at least the notes will be always there. Okay. Any criticisms or
any special requests?
Coffee. Request.
Besides coffee and Kannelbunna and Cloud Kaka and all this stuff, we don't have sponsors to buy this for us right now.
I might become the sponsor.
Yeah, well, that's what we did at the Uppsala Big Data Meetup. We just kind of took turns by getting some fika bread, so that's knock yourself out.
Maybe we should broadcast this to YouTube.
All right, so
200 people with that.